volume. So that's the airflow that goes into and out of your respiratory tract on quiet breathing. All right, so this number here is our tidal volume. If we were to take a maximal breath in, to breathe in as much air as we possibly can into our lungs or into our respiratory tract, we would call that our inspiratory reserve volume. All right, so this inspiratory reserve volume is the amount of air additional to a normal breath that we can breathe in. It's what we have in reserve. So if we need an extra airflow, then this is the extra airflow. All right? If we take a maximal breath out, or we exhale maximally, the amount or the volume of air that we can expire would be our expiratory reserve. Now there is a volume of air, an amount that remains in your lungs when you breathe out maximally, because we have to keep our lungs inflated. So this volume is referred to as residual volume. It is the residual air that we cannot possibly breathe out, no matter how hard we try, because our lungs must remain inflated. Now, based on these volumes, we can use them to calculate some capacities. So the volume is just a measurement. A capacity is like a rating. Okay? Here you have a cup. The capacity is 20 ounces for your coffee cup. So if I fill it to the top, it is considered at capacity. All right, so when we're looking, we would say, what is the capacity or the rating for our lungs on our inspired air? So the total amount of air we can breathe in. We would call that our inspiratory reserve capacity, and so that would include our tidal volume and our inspiratory reserve volume. All right, so we would call that our inspiratory capacity, or IC for short. And so if we were to calculate that inspiratory capacity, we would say that's the same thing as taking tidal volume plus our inspiratory reserve volume. All right, so if I want to say how much air can you hold in your lungs on inspiration, right, you would calculate this capacity. So to do that, you take the tidal volume and add it to your reserve. Now if I said I wanted to assess all the air that we can physiologically interact with, so everything that I can inspire, everything that I can possibly expire, we call that our vital capacity. All right, so with our vital capacity, it is equal to our inspiratory capacity plus expiratory reserve volume. All right, so everything we can inhale or inspire plus everything that we can expire or get out of our lungs. If I want to say what is the total capacity or the total amount of air that can be in my lungs at any given time, we're looking at the entire volume, right? The total number. So we would take for the total lung capacity, we would take our vital capacity and then add in the residual volume. The purpose of this, clinically, is to assess the amount of air somebody can move. Right? So understanding that the air we breathe is made up of oxygen going in and carbon dioxide going out, and so the amount we move in and out reflects how much oxygen we can get into our system, inspiratory, how much carbon dioxide can we remove from our system. And so these are total numbers. We would then take this over time to get some other values. We'll talk about those in lecture. But for our purposes today, and what we're going to measure, we're going to get some numbers collected from our class. Right, now, the experiment I mentioned is an experiment where we're going to compare the volumes that we can produce when we are breathing with our shoulders. So you're taking your deep breath or inspiratory capacity by breathing through your chest and your shoulders, compared to when you're taking that deep breath cued through your abdomen. And we're going to compare those numbers. We'll calculate our vital capacity and compare that to our vital capacity with the other type of breathing. We'll calculate our total lung capacity and compare that to our total lung capacity with the other type of breathing. All right, so I have data tables set up, so you're going to check that or give me your data after you've collected it, and I'm going to plug it into some tables. We'll give you some results, and then based on those results, you're going to take a critical view of this experiment and draw some conclusions. I'm going to have you answer some questions, then we'll discuss our thoughts on this experiment, whether it's good, bad, whether we can use it as an Instagram headline. Should we all get on social media and publish this in bold type and say, breathe through your stomach, right? Or should we look at how we could make it better in the future? What would we do if we were researchers trying to get some more grant money to do some more experiments, right? Because that's part of their job, is how do I get paid again? So I got to come up with a good piece of research or a good idea, so somebody will fund me so that I can, one, get paid, and two, possibly provide some information that would add to our understanding of the human body. So next Tuesday, we'll take our data we collect today, and I'll give you the set along with kind of a worksheet type activity. You're going to go through and answer some questions, and then we'll have some discussion on how we can improve this in the future. And the idea is, progressively, as I have more and more AMP2 classes, I'm going to keep collecting more and more data and tweaking the experiment every time. So I'm going to start getting some longitudinal information, and we're going to start getting more students involved as far as the next term students in the summer and in the fall, and over time I'll have this data set to say at Iowa Western, these are the capacities or these are the volumes of students that breathe this way versus this way, and this is the conclusions we're trying to draw. So we'll kind of add to this experiment as we go and make it a little bit more relevant by getting some more numbers. But the benefit to you is you get some experience at seeing, okay, how would somebody carry out an experiment, and then what would we do once we're done? Right? How do we determine if it's good, if it's bad? So we'll talk through some of those processes. So what you'll need to do today, I have some computers, I've got 4, so we'll have 4 stations, and you are going to set up, or I'll help you set up the probeware through this vernier, and on the laptops that I have, I've got 4 laptops to set up the stations. You are going to measure your lung volumes, both breathing with your shoulders once, and then once breathing with your abdomen. I'll kind of walk you through the procedure and how you do that after we get everything set up.
It's as a group or group it all?
Each one of you is going to do it individually. You can work as a group and help each other, but each one of you will get individual values. And this will be anonymous, so as you go in, I'll tell you your student, 14 or your student 15. So you can know when you look at the data table what's yours, but it will be anonymous as far as the data collection goes. Right, so we're going to calculate, we'll measure our tidal volume, we'll measure our inspiratory reserve volume, we'll measure our expiratory reserve volume. All right, for each of these types. Through those measurements, we are going to calculate our vital capacity and our total lung capacity. We also have in our lab manual a chart that tells you what your predicted lung capacity would be based on your height and your age. And now, it would make sense that a larger person would have a larger lung capacity than a smaller person, right? So we want to evaluate this based on our predicted ranges. So to control, to make sure our experiment is within the realm of reason, that we're not getting 10 liters more volume on our measurement compared to what our predicted range is, this is going to help us standardize our results. Make sure we're not deviating too far from our established ranges. So if you are going to calculate out your predicted volume, you'll need to have your height in centimeters. So you take your height in inches and multiply that by 2.54, and that will give you your height in centimeters. So then you come to the chart. There's a female and a male chart. You just go to your height in centimeters that you calculated, and you go to your age range, and then you pull that number for your predicted vital capacity. I'm going to point out here, on the chart that we measured, it will show our number in liters. So when we pick up this volume here, it might say 1.2. Right? Whereas we look over here and it says 1,400. 1,400 milliliters, which is what this chart is in, is 1.4 liters. All right, so we'll have to do a little converting to compare, but I can help you with that if you're having trouble. Because once we walk through, or once you get all your values collected, and then you calculate your capacities, then you'll come up and you'll give me your data, and I'll plug it into our data chart, and then we'll bring that data back around on Tuesday so we can do some critical analysis of this information, of this experiment. See if what we thought was what we thought. All right? For the test, you're going to see a chart like this, and it'll have A, B, C, D, and I'll say which letter, or letter B represents which volume, or letter C represents which capacity, or the value represented by letter A added to the value represented by letter C would equal what? And you can say, oh, that's inspiratory reserve capacity, something along those lines. All right? So that would be how this station will set up on the lab exam. It'll be a chart, it's labeled, and you will have to come up with the terms for the appropriate volumes and capacities. So we'll start getting set up here.